Now let's continue further with our topic of conic sections with its first shape of geometry, which is parabola. We have already studied a bit of the terminologies that are going to be used in this chapter in the earlier introductory video. So definitely go have a look before you come to this video. Let's look at the subtopics that we need to cover. We'll look at a brief introduction as to how parabola works, its equation, and a few terminologies. We will revise it quickly that we had studied in the introductory video. Then we'll look at the standard forms and the parametric forms of our parabola. And then we'll look at the position of a point. With respect to a parabola, how can we say whether a point is lying inside, outside, or on the parabola? Apart from point, we will also look at the position of a line and the position of other parabolas with respect to a given parabola. Then we'll look at the topic chords. Initially, up until JEE Mains 2024, there used to be normals, tangent, their equations, and a lot other things involved in the syllabus. However, this year JEE Mains has reduced the syllabus by a vast amount. So that is why there is not much information that you need to remember or study in this chapter. The only thing is your logic and your visualization of the coordinate geometry would help you solve questions on this chapter. So let's start. Again, we had already studied what a parabola is. It is the locus of a point which moves in such a way that its distance from the focus, we had studied focus, and its distance from a fixed line, which is our directrix, is same. So here, for a parabola, we had studied eccentricity is equal to 1. And we remember eccentricity used to be equal to PF by PM. So we had studied a parabola to be in this manner where here we have our focus, here is our vertex, and this is our directrix. And we remember if we take up any point P on the parabola, then the distance of PF would always be equal to the perpendicular dropped, the foot of perpendicular, which is our M. So now generally, if let's say someone gives you a question where they've mentioned the focus points and they've given you the equation of the directrix, then would you be able to find the equation of parabola? Yes, it is very easy. You know this equation E is equals to PF by PM, and you know for a parabola E is equals to 1. So PF is always equal to PM. And from here, you can calculate the equation of our parabola. You know the points of focus. So for here, you can use the distance formula. We had studied the distance formula at the straight lines chapter. And you can also find out the distance, perpendicular distance of a point from a line as well. You had studied this in the formula of the foot of perpendicular, again in straight lines. So yes, all these things can be done, and through this you can find out the equation of a parabola. Now, a few things that you need to remember, that a focus is always a fixed point. We had studied all these things, just a revision before we get into the depth of parabolas. There is a directrix, which is the fixed line, and then we have the eccentricity, which is our fixed ratio. Important thing to remember. So let us revise all the terminologies about parabola that we had studied. So this is our axis, this is our parabola, and this is our directrix. So this is directrix, this is our axis. Here we have our vertex, here is a focus, and this is our parabola, whose any point P, x comma y is at an equal distance from the focus and from the perpendicular distance of this line. Now, apart from this, we had also looked up onto the chords of a parabola. If you remember, what is a chord? A chord is any line which intersects your curve at two different points. How if let's say the straight line would have intersected my curve at only one single point, then it would have become a tangent and it would not remain a chord. So here, let's say this line, this intersects it at two different points, so this becomes a chord. Now we had also studied a little at the end, if let's say the chord is perpendicular to the axis, then this chord is known, this is a chord, and this chord is known as a double ordinate. So whenever in a question they mention you anything about the double ordinate, you know that this is a chord which intersects the axis at right angles. And now if this double ordinate, let's say, passes through the focus, this is 90 degree, this is our focus, this is a chord, and it passes through the focus, then this is known as latus rectum. And this is an important terminology, latus rectum. You will need to use this a lot throughout the questions, be it of parabola, be it of ellipse, or be it of hyperbola. Generally, they ask you the length of latus rectum, or sometimes they ask you the equation of latus rectum, or sometimes they will provide you with the information of latus rectum, and you would be asked to find out other terminologies of that conic section. So this is an important thing to remember. Again, repeating, what is a latus rectum? It is a chord. It is a chord which is a double ordinate, of course, because it is perpendicular to the axis. Double ordinate. And this double ordinate passes through the passes through our focus. That is why it is known as a latus rectum. Now let's look at a question to get our concepts about the equation of parabola a bit more strong. Find the equation of the parabola whose focus is this and the directrix is this. So as I had mentioned, the equation of directrix has been provided to you and the point focus has been provided to you. So how are you going to find the equation of our parabola? Let us first draw the diagram. Just remember one thing, whenever you are solving questions of coordinate geometry, it is necessary for you to draw diagrams. This would make your solution even more easier. This is our focus, which is minus 4 comma 2, and the equation of our directrix is x plus y minus 3 is equals to 0. So now let us take up a point p x comma y here, and we know that the distance of pf and pm, the foot of perpendicular here, would always be same. Since we know for a parabola, eccentricity is always equal to 1, that means pf would be equal to pm. Thus, we can find out the equation of our parabola using this equation. We know how we can find out PF using the distance formula, which is x plus 4 whole square plus y minus 2 whole square. And what would be our PM? If you remember, while studying foot of perpendicular in straight lines, we had also studied to directly find out the distance of a point from a line through a perpendicular distance. And that used to be x plus modulus of x plus y minus 3, the equation of the line, divided by root under 1 whole square plus 1 whole square, the coefficients of x and y. So we've got this equation. Now once we simplify this, we will get our answer, and that would be our equation of parabola. So let us square both sides so that the roots get removed and the modulus gets removed and it becomes easier. So this would become twice of x plus 4 square plus y minus 2 square, and this is equal to x plus y minus 3 whole square. Let us take this to the new page. So it is x plus y minus 3 whole square. This is equal to twice of x plus 4 square plus y minus 2 square. Let us simplify this. So we would get x square plus y square plus 9 plus xy minus 3x minus 3y. This would be equal to 2x square plus 32 plus 16x plus 2y square plus 8 minus 8y. Let us bring this equation this side. By subtracting all the terms from this side, we would get x square plus y square minus xy plus 16x plus 3x. We would get plus 19x minus 8y plus 3y. We would get minus 5y and we have here 8 plus 32, which makes it 40. 40 minus 9 makes it plus 31 equals to 0. So this is our equation of the parabola. Now let's say if you were to check whether the answer that you've taken out is correct or not. So you can use the discriminant formula, the shortcut trick that we had studied. You can write this equation as ax square plus bxy plus cy square plus dx plus ey plus f is equals to 0. And then you can take out the discriminant, which is b square minus 4ac, and then check whether it satisfies the condition of our parabola or not. And that is how you can check whether the equation that you just found out through using this formula of pf equals to pm is correct or not.